Hey everybody, Kyle here. I wanted to talk through some of the engineering productivity performance indicators ahead of the quality leadership meeting. I picked out the four measures that we have related to stability, efficiency, and effectiveness. And I want to talk about kind of the last few months and what's coming up ahead. So we'll start off talking about master stability here. So this is important from this is an important metric to make sure that we have stable pipelines executing that reduce impact of problems into merge requests and allows work to flow through smoothly. You can see a dip here in May. This is mainly due to some runner changes, which caused problems retrieving the code base for the GitLab mono repo in CI, a CNG upstream dependency issue, which caused problems with our scheduled pipelines. There's 12 of those per day over the span of about a week. And then we had an increase in flaky specs, which I'll talk about here in a little bit. The percentage of attribution of each of those reasons is really hard, or is challenging because they were all happening simultaneously. So that's not necessarily clear to say this one reason was the factor for a particular pipeline. In a number of cases, we had some overlap between, especially the runner problems and the chart problems. I think looking at the 10-day moving average here metric allows you to see a little bit of this unlucky stretch, I'll say, where we had the combination of errors here. You can really see in the middle of May here, we dipped to a historic low, I would say, or at least match a historic low of below 70%, and recovered as we fixed the runner problem. Distribution was able to get a fix in on their chart problems, and then we took some faster action on flaky specs. So looking ahead, the two things that we want to focus on here is being able to more accurately measure, I'll say, test health metrics, so that we can, at a spec level, so we can, with higher degree of certainty, say, here are the number of master pipelines, MR pipelines that failed related to a particular spec problem, so that we can define acceptable thresholds of those health metrics and take automated actions like quarantining when the health dips below a threshold. And then one of the other trends we're seeing recently is an increase in Foss related errors. So these are errors that would happen in the GitLab Foss project when all the EE code is removed. We have some testing jobs that simulate Foss changes in the mono repo. However, we need to look to expand those a bit to our front end jobs, because we're seeing an increase of the rate of ESLint, Jest, and a few other front end specific failures that are happening just in the Foss repo, which blocks a portion, probably about 15% of MR pipelines when these happen, as well as usually lead to a revert, which causes rework for an engineer on the team. So now I want to talk about review app deployment success rate. Review apps are used for end-to-end and exploratory test feedback, and the success rate at which those environments can be available on MRs helps to make sure that that feedback can happen quickly and accurately without a lot of manual intervention to diagnose maybe cluster-wide stability problems and things like that. We also had a decrease in this metric for May. Ken already touched on the upstream issue that the distribution team helped us resolve. One of the things to note is that looking in probably Q4, late Q3, but more likely Q4, engineering productivity will be partnering with distribution to see how we can build the images that end up getting deployed in review apps from a stable reference as opposed to the current default branch. That would allow us to work around the issue that we encountered easier and really reduce that overall impact that was happening to review app pipelines. The other thing I want to talk about review apps is we've been expanding review apps over the last 6 months. So you can see this green bar represents the proportion of MR pipelines that have a deployed review app. This has really been around, I'll say, like 30% historically. You can see this ramp up happening here starting in January, as we've expanded the files that are changed that require end-to-end test feedback to happen on a merge request. We've also made those jobs blocking MRs instead of allowed to fail, so that we can start catching problems that would surface on the path to production and create reactive work for SETs and the delivery team faster. And I think anecdotally, so we're looking to pull together evidence with quality engineering on this, but anecdotally, it seems that the frequency of review QA block or QA test blocking a deployment has gone down based on feedback from the delivery team. Next, I want to talk about time to first failure, also known as TIF. So this metric is helps us identify how fast actionable feedback on merge request pipelines is delivered to team members to act on. It's calculated by looking at the pipeline start time and comparing that to the first build failure time for failing MR pipelines. You can see this metric has been a bit volatile over the last 6 months. This is mainly due to the trend that I just talked about, where we've been increasing the end-to-end tests happening. That changes the proportion of end-to-end test failures that happen on MRs compared to historical trends. And those end-to-end test failures are traditionally much later than unit integration system test failures that might happen in the same MR pipeline. The other thing that we've been seeing is we've taken a stronger stance with code coverage and really in trying to fail MR pipelines if new code is introduced without RSpec test coverage. Lately, we've been seeing a few situations that have been causing this to fail more frequently. So you can see here our two most frequent failures for TIF are review QA reliable, which happens at minute 87 on average in the pipeline, and under coverage. For under coverage, we're looking to address two of the specific root causes of non-actionable failures here during 15.2, so that we can reduce the rate of that failure, or at least the reduce of the inactionable failures. And then for review QA reliable, we're going to be optimizing the review app pipeline deployment path so that these so that review QA jobs will start sooner in the pipeline. So we're looking at the number of dependencies until a review end-to-end test starts running, and looking at how we can minimize those, or how we can accelerate the build times for the deployed images, the review app that gets deployed, all of those things, so that those review QA tests can start sooner and hopefully fail sooner as well. Lastly, I want to talk about duration. So merge request pipeline duration is similar to time to first failure, but it's looking at the duration for passing merge request pipeline. So this would be like the normal, this is reflective of the normal cycle time of MR pipelines. The reason why this is important is this metric can really hold back the timeliness, or limit the timeliness to resolve GitLab.com reliability and stability issues. So at a high level, a change, whether it's a revert or a bug fix or something like that that needs to go out for a P1 to S1, has to wait for this whole cycle until it can start the deployment process. So driving this down gives us higher resiliency for faster recoverability from system problems that we have on GitLab.com in particular. You can see this has been trending up. Again, this has been, I'll say, duration metrics haven't been looked at as much as cross-functional efforts that engineering productivity has been involved in, like next prioritization, expanding code owners, and things like that. Looking ahead to Q4, we'll be working on the items I just talked about for time to first failure, which will also drive this down. And then we'll also probably be looking at specific revert path options, as well as opportunities to ensure that our recoverability for GitLab.com can happen in a timely manner. those are the 4 metrics I want to talk about. I hope this is all helpful. Happy to dive into more specific data during the leadership meeting if need be. We have a lot of, I'll say a lot of different contextual measures that can help provide more context into these KPIs and PIs that are really, really kind of high level and removed from the detail.